Zeal Education Society, redefining excellence.
In continuation with the solution of linear differential equation with constant coefficients, again we are going to solve some problems on linear differential equation with constant coefficients. So for the sake of simplicity, I will call those methods as general method and short method. The problems on general method. Here in general method, the integration is required, and wherever the integration is being complicated, in that case you can use short method. The drawback of this method is the integration. If the integration is being complicated, then it will take more time to solve, to get the solution. Now, we are going to solve problem on general method. Solve the differential equation. Solve the differential equation. d2y by dx square minus 6dy by dx plus 9y is equal to e to the power 3x by x. This differential equation we are going to solve. Here, so far we discussed the solution of the differential equation where right hand side was 0. If right hand side is 0, particular integral is going to become 0. Pi is going to become 0. Here the right hand side is not 0. The solution of the differential equation, there are two parts of the solution. First part is complementary factor and other one is particular integral. So for complementary factor, I am writing this equation, directly writing. I am writing this equation in terms of d, in terms of capital D. I have written this equation because capital D is d dx and capital D square is d2 dx square. Now auxiliary equation is d square minus 6d plus 9 equal to 0. And if you find values of d, the two values of d you will be getting, the d is what? 3 and d is 3. Is two values of d we got, and these values of d means roots of an auxiliary equation are real and equal. Roots of an auxiliary equation are real and equal. If roots of an auxiliary equations are real and equal, the complementary factor is c1 plus c2x outside of the bracket e to the power 3x, because 3 is the root. These two roots are repeated roots and real roots. This is the complementary factor. Now particular integral. How to find out the particular integral? So this coefficient of y, I am shifting on the right hand side, 1 by d square minus 6d plus 9, and this operator I am operating on e to the power 3x by x. This I have shifted, this operator I am shifting on the right hand side. So this is the particular integral. Now we are going to operate this operator on this. First of all, you factorize this operator. This is d minus 3 and d minus 3 are the two factors of d square minus 6d plus 9. Now, here 1 by d minus 3 and 1 by d minus 3, the same thing I am operating on e to the power 3x by x two times. So when you operate it, so this important formula you have to use. What is the formula? 1 by d minus a on function of x, capital X is a function of x, is equal to e to the power ax integral e to the power minus ax multiplied by capital X or uppercase x dx. Okay, in this way. Once again, 1 by d minus a x e to the power ax outside of the integral and inside of the integral e to the power minus ax x dx. Dx is there because we are integrating with respect to x. Now this thing in continuation, particular integral. What I am going to do, 1 by d minus 3, this 1 by d minus 3, this 1 by d minus 3 I am operating on e to the power 3x by 3 using this formula. 1 by d minus a is what? E to the power ax integral e to the power minus ax into x. X is e to the power 3x by x. E to the power 3x by x. This dx is there due to because we are integrating with respect to x. Now try to simplify it. If simplification is possible, you can solve for one more step. If there are some cancellation or reduction in terms that can be done, e to the power 3x into e to the power minus 3x by law of indices, e to the power 0, e to the power 0 is 1, means only 1 by x will remain. And integral of 1 by x is what? Integral of 1 by x is log x. Now what I am going to do, again one extreme right operator means 1 by d minus 3 I have operated. One more 1 by d minus 3 is to be operated now. Again I am using this formula. What is the formula? E to the power 3x integral, this is our capital X now, integral e to the power minus 3x multiplied by capital X, it is e to the power 3x into log x. Due to this integral sign, I am putting here dx. This is as it is, e to the power 3x, e to the power minus 3x multiplied by e to the power 3x, e to the power 0, e to the power 0 is 1, only log x is remaining. Now integral of log x, it remains to find out value of integral of log x. So how to find out integral of log x? By integration by part. Okay, now I am using integration by part. First function into integral of second minus integration of derivative of first, like that. Okay, first function is log x and 1 is the second function. Integration by part I am using. Okay, integration by part I am writing here. If you have forgotten, if u and v are functions of x, then first function integral of second minus integral of derivative of first function into integral of second, and this whole thing is to be integrated with respect to x. Okay, this is integration by part, simple integration by part. The same thing I am using here. First function, log x is the first function, because of the LIAT rule, first function into integral of 1. Integral of 1 is x. Integration of 1 with respect to x is x, minus integral of derivative of first function, derivative of log x is 1 by x. And integral of 1 is x here. Integral of 1 is x. Here, the integration by part I use. I repeat, first function, this is second function, first function integral of 1 minus integral of derivative of first function and integral of second. E raised to power 3x as it is. Here x log x minus, this x gets cancelled and 1 will remain, and integral of 1 is what? Integral of 1 is x. So this is particular integral here. Particular integral. Okay. Now, the solution, when the integration sign is released, we have to put the integration constant, but in solution of differential equation, I'll avoid to put it, because that general constant is compensated, the value of the general constant is compensated in the general constant which are being used in complementary factor. The solution of the differential equation is what? Y is equal to complementary factor plus particular integral. y equals what? Complementary factor is what? C1 plus C2x e to the power 3x, and particular integral is e to the power 3x x log x minus x. Okay, this is the complete solution of the differential equation. Here this is complementary factor and this one is particular integral. This is the value of y. Means we have solved the differential equation. We have solved here the differential equation. Now one more sum on general method. Okay, solve the differential equation d2 plus 3d plus 2. You don't forget that capital D is derivative with respect to x. Y is equal to e to the power x. What is the function? D square plus 3d plus 2 outside of the bracket y and e to the power x. This we are going to solve. Just I am going to write complementary factor very quickly and then particular integral, because you are aware that how to find out the complementary factor in short. The solution of the differential. We are going to solve this problem. This auxiliary equation I am writing directly because this is left hand side is already given in terms of capital D, and the value of D, use calculator and get the value of D. It is -2 and -1. Okay, what are the factors? D plus 2 and multiplied by D plus 1, therefore D values of D. Here complementary factor is, these values are real and different values. Real and different. Okay. Therefore, C1 e to the power minus 2x plus C2 e to the power minus 1x or minus x, simply you can write. This is complementary factor. Now, the particular integral we are going to find. The particular integral is what? Particular integral, this bracket of D means coefficient of y, I have to shift on the right hand side, 1 by d square plus 3d plus 2. No doubt if you shift on the right hand side, it will be in the denominator, e to the power x. Now, as we have discussed earlier, to factorize this, d plus 2, d plus 1. We have factorized it. The function is e to the power x. Now, operate 1 by d plus 1 operator on this capital X, and the resulting thing will be operated by 1 by d plus 1. 1 by 1 you have to operate operator in general method. So 1 by d plus 2, I am operating 1 by d plus 1 on this thing, this function. 1 by d plus a, see here 1 by d plus a on x e to the power ax minus x e to the power plus x. Here I have written formula for minus a. Okay, 1 by d plus 1 I have to write. So it is very clear that e to the power, this I am writing, e to the power minus x integral e to the power x e to the power x. Okay, if you use the formula, if you relate with this formula, here a is minus 1 like that. A is minus 1 like that. Now the integral of e to the power x into e to the power x I want. The integral I am writing here separately. See, the integral I am writing separately. Integral of, see, when you integrate e to the power fx, when you integrate e to the power fx function, but here fx is the argument of exponential. If derivative of the index of e, if the derivative of its argument is repeated in the multiplication f dash x, then the integration of complete term is e to the power fx. E to the power fx. For example, if you integrate e to the power x square and the power of e is x square, its derivative of the argument is being repeated in the multiplication. Derivative of x square is what? 2x. Then integration of total thing, integration of total term is what? E to the power x square. Okay, in short. Okay, no need to substitute e raised to power x equal to t and then, okay, no need to waste time on doing the thing. 1 by d plus 2. Here, e to the power minus x is outside of the integral. Here, e to the power fx and its derivative is being repeated here. See, e raised to power x derivative is what? E raised to power x dx. Derivative of e to the power x is being repeated in the multiplication. Therefore, integration will be what? E to the power fx. So we reach up to, in this way we have operated operator 1 by d plus 1. Once again I repeat, integration of this, either you can put e raised to power x equal to t as we have done in earlier years in 11th standard, 12th standard, or you can use this type of shortcuts while solving integration. The power of e is e raised to x and the derivative of the power of e is present in the multiplication. Then integration of total term will be e to the power that argument. Okay. Now we are going to operate. Now we are going to operate operator on which operator we are going to operate? We are going to operate operator on 1 by d plus 2. See here, 1 by d plus 2. 1 by d plus 2 particular integral. I am operating on e to the power minus x into e to the power x. Okay, this 1 by d plus 2 operator I am operating. Now, how to operate it? Again using the same formula. 1 by is how to write it? E to the power minus x minus 2x integral e to the power 2x due to this 2. Okay, e raised to power minus x and e to the power x. Okay, 1 by d plus 2. 1 by d plus 2, which formula? This formula I am using. See, 1 by d plus a, you can write in terms of a also, x e to the power minus ax integral e to the power minus plus ax into x dx. Right? Now, so we are going to operate operator on it. Is it? Now, e to the power minus 2x is there and multiplication of e raised to 2x and e raised to minus x is e raised to power x. Therefore, e raised to power minus 2x and derivative of power of e is present here. Therefore, integration is what? Integration of total term as we have done in the previous page is the same thing. Therefore, solution is what? Y equal to Cf plus Pi and y is equal to putting value of Cf. What was Cf? C1 e raised to minus 2x plus C2 e raised to minus 1x plus particular integral e raised to minus 2x multiplied by e power x like this. Okay. Now this is the particular integral, this is the solution to the differential equation. Okay, one more thing I want to clarify. If this type of situation comes while integration, okay, while integrating the thing, this type of situation comes. Here I am writing, because it is depend on the complementary factor here. It is, see, suppose this type of integral is there. If you come across this type of integral, how to do it? How to do it? Power of e to the power x is what? E to the power x. Derivative of power of e to the power x is e to the power x. But here we have e to the power 2x. So what I am going to do? E to the power 2x I am breaking like this. I am splitting like this in this way. E to the power 2x, I am splitting in this way, e raised to x power x into e to the power x by law of indices. Now, the derivative of e to the power x is not being repeated here. In addition to these, other functions are also present. So here you can put e to the power x equal to t. Then if you put e to the power x equal to t, the e to the power x dx is equal to dt if you take differential of both the sides. If you take differential of both the sides like this, then this integral will be e to the power x is t, e to the power x dx is dt, and e to the power x is e raised to t. See, try to understand. We are solving this integral. Why I am telling you? Because while solving problem, you may come across this type of integral. And how to solve this integral? Because derivative of the argument of e is not being repeated in the multiplication. That's why I have splitted it up like this. Okay. And substitute e raised to power x equal to t. And e raised to x dx is dt in this way. Now, you can easily take integration of t e raised to t by integral by part. I am using generalized by part. First function, integral of e raised to t is e raised to t minus a generalized rule of integration by part is convenient when one of the function is algebraic, and that should be treated as the first function. T is algebraic, t square, t cube, algebraic function. X square, x cube, x to the power n, algebraic function. Okay. Now, first function, generalized by part, first function integral of second minus derivative of t, here I am writing, derivative of this, and integral of e raised to t, here I am writing. After that, then after minus plus I have to write, the derivative of 1 is what? 0. And one of the term is 0, then the resulting thing will be 0. Therefore, the series is being terminated here. The t e to the power t minus e to the power t is integral of t e to the power t. And finally, after integration, the put value of t in the last step, t is this, t is this, t is this one. This is integral of e to the power 2x e to the power x. Yes, why did I explain it? Because while solving this type of problem, you may come across this type of situation. Okay. Now, very quickly, I'll go slightly fast for the third one. Solve the differential equation. Solve the differential equation. Solve the differential equation. D square plus d of y is equal to 1 by 1 plus e to the power x. This differential equation we are going to solve. I will increase slightly the speed of writing. The auxiliary equation is d square plus d equal to 0. Then take d common, d plus 1 will be there. Either d equal to 0, you can use calculator or you can find out value manually also. But I will recommend you to use calculator. complementary factor, these roots are real and different. These roots are real and different. Therefore, complementary factor is c1 e to the power 0x plus c2 e to the power minus 1x. Okay, e to the power 0 is 1, c1 plus c2 e to the power minus x is complementary factor. Okay, it's very quickly I have written because we have now the sufficient practice on complementary factor is done. Okay, what is complementary factor? C1 plus C2 e to the power minus x. This is a complementary factor. Now, particular integral. Particular integral is 1 by d square plus d. Is this coefficient of y I have to shift on the right hand side? 1 by 1 plus e to the power x. Okay. Now, after shifting this coefficient of d on the right hand side, this operator on the right hand side, so we have to factorize it. Just you factorize, take d common, d plus 1 in this way. Okay. Now we have the product of two operators. What is the first operator? Is d plus 1 and then other one is d. The particular integral I am operating 1 by d plus 1 operator. The 1 by d plus 1 is what? 1 by d plus a is what? E to the power minus 1x integral e to the power 1x d plus 1 is there. 1 by d plus a on this right hand side. 1 by 1 plus e to the power x. Okay. We have operated 1 by d plus a on this thing, 1 by d plus a on this thing, right? Now, 1 by d e to the power minus x is outside of this integral e power x by 1 plus e power x. Okay? So, this integral I want. But when you solve integral, you have to be very alert because we want integration of the function in minimum time. We don't want to waste our time on integrating the thing in lengthy way. So how to, if you look at this function very carefully, the integration of this will be what? Integration of, if you look at the numerator and denominator function, see derivative of numerator is present in the, derivative of denominator is present in the numerator. Integral of, in the denominator a is there, suppose, and derivative of a is present in the numerator, the integration of total thing is what? Log of a. So similarly, derivative of 1 is 0, derivative of e to the power x is e to the power x, means derivative of denominator is being repeated in the numerator. The integration of total thing is what? Log of 1 plus e to the power x. Okay. Now 1 by d I have to operate. So use 1 by d plus a formula. Use 1 by d plus a formula. Or you can directly write 1 by d is integration with respect to x. D is what? D is derivative with respect to x. And 1 by d is integration with respect to x. So take integration of e to the power minus x into log of 1 plus e to the power x. Okay. 1 by d is what? Integral of this. You can use 1 by d plus a formula also and put a equal to 0, and in that way you can go ahead. Or 1 by d is integral directly. Now use by part here because we have the product of two functions and we are integrating it. There is a log function, there is exponential function, and as per our rule of partial by part, the log should be selected as the first function. This is first function, this is second function. Okay. So very quickly by part I am using, but I am using here regular by part. I am not using generalized by part. When generalized by part is preferable or recommended, when one of the function is algebraic, in that case you can use generalized by part. Here I am regular by part. I am using first function into integral of second function. Integral of second is e raised to minus x integral e raised to minus x by into minus 1 minus integral of derivative of first function, derivative of log of argument is 1 by argument, and derivative of argument again. Okay, then integration, derivative of this and integral of this. Integral of e raised to power minus x is what? Minus e raised to power minus x. Now log of 1 plus e to the power x as it is, e to the power minus x is as it is, this minus sign I am bringing here, this minus plus, e raised to x, e raised to minus x, its product is 1, I am writing 1 plus e to the power x dx. Okay, now the integral of 1 by 1, integral of, instead of finding their integral, I am finding integral of this separately. 1 by 1 plus e to the power x, its integral we want. I am evaluating integral of 1 by 1 plus e to the power x separately. That integration with respect to x, no doubt. But here also we have taken this type of integral. But what is the difference between these two integrals? In this integral, derivative of 1 plus e to the power x is present in the numerator. But here, the derivative of 1 plus e to the power x is not present in the numerator. In this situation, what to do? Whenever exponential functions are present in the denominator and its derivative is not present in the numerator, in that case what to do? Multiply it by its conjugate, means e to the power x is there, multiply by e to the power minus x to the numerator as well as denominator. 1 multiplied by e to the power minus x and e to the power minus x multiplied by e to the power x is 1. Okay, in this way, or you can take e to the power x common also, in that way you can do. It is your choice. But here what happened? The exponential term is present in the denominator and its derivative is being repeated in the numerator. What is derivative of e to the power minus x plus 1? What is derivative of e to the power minus x plus 1? Minus e to the power x is the derivative of denominator. This minus I am going to add here. Is it? Now, derivative of denominator is present in the numerator. Therefore, by this way, log of denominator is integration. Log of denominator is integration. Yes, in this way, we found integration of 1 by e to the power x separately. Now here I am putting the value log 1 plus x e to the power x multiplied by e to the power minus x, and its integral is log of minus is there, log of e to the power minus x plus 1, in this way. So this is particular integral, and solution is what? Solution is complementary factor plus particular integral. What is complementary factor? This is complementary factor, this is particular integral. You put the whatever the complementary factor we have obtained and the particular integral, that will be your solution to the given differential equation. Okay, now we are going to discuss one more method on solution of linear differential equation with constant coefficient. That is called the short method. The short method, general method, those methods is the name of those methods is fully depend on us how to call it, See, now this I am calling is short method, short method. Yes, what is the advantage of short method? Here integration is not required directly. There in general method, the 1 by d plus a over x, and in that way integral is required. But in short method, integral is not at all required. But there are few ways to operate the operator. see, I am operating, the first case, I am operating 1 by ft operator on e to the power ax. Okay. So how to operate operator? How to operate operator? So replace d by a directly. Replace d by a directly. In this way operator will be operated. But important thing is that provided this f of a is denominator is not equal to 0. You can directly put d equal to a, substitute d equal to a and operate the operator. But in that case, after operating operator means after putting d equal to replacing d by a, then you should not get 0 in the denominator. If it happens, if f of a is 0, if f of a is 0, then what to do? How to operate this operator? So write down x outside of the operator, write down x outside of the operator and take derivative of operator with respect to d. Take derivative of operator with respect to d. By putting d equal to or by replacing d by a, if you get f of a equal to 0, then what to do? Write down x outside of the operator and simultaneously take derivative of denominator separately with respect to d and then operate operator. X, replace d by a now, f dash of a on e to the power x. Provided f dash of a is not 0. F dash of a is not 0. And you have to continue it. If f dash of a is 0, then what will happen? Write down again x outside of the operator and take derivative of f dash d. That will be, you can call it as a prime or a dash, f prime a and or f double prime d in that way. Okay, continue this procedure. Now, so how to operate operator on sin ax and cos ax function. Sin ax or cos ax function. A is constant. Okay, x is variable. On sin ax and cos ax function, so we have to replace this. First of all, I am writing this fd operator in f of d square. Okay, in this way. Sin ax and cos ax or cos ax. So why did I write so? Because when you operate operator on sin ax or cos ax, so we can replace d square by minus a square only. We don't have facility to replace d by any other constant. We have to replace d square. Our target is d square. So now replace d square by minus times a square. Okay, provided phi of minus times a square is not equal to 0. If it is 0, then continue the previous procedure. If phi of minus a square is 0, then what to write? Then write down x outside of the operator, take derivative of operator with respect to d is derivative of denominator only, and sin ax or cos x. And continue the procedure. Okay, and this can be written as x 1 by f dash d, or I am writing in terms of d square now. When we solve problem, it will look very simple. Only as a formality, I tell you in general what happens. Okay. Now, some problems we are going to solve. Solve the differential equation. First problem, or short method, solve the differential equation d2y by dx square plus 5 dy by dx plus 6y is equal to, e to the power 3x in this way. What I am going to do, I am going to solve this differential equation. Means we have to find complementary factor, particular integral, and when to use short method and general method. So how do you choose the method? That selection of the method is important. If we have exponential function e to the power ax function only, sin ax function only, or algebraic function only, means x power 2, x power 3, like that. In that case, try to use short method, because if you use short method and this type of function appears on the right hand side, the solution you will be getting in minimum time. But you are free to use general method everywhere. But what is the drawback of general method? What is the limitation of general method? General method requires integration, and many times if the right hand side functions are complicated, the integration will be very lengthy. So I repeat, when we have on the right hand side exponential function e to the power ax type, or sin ax type, or x to the power n type, where n is a positive integer, in that case use short method. Okay, so here very quickly I am going to write this. I am writing in terms of d, capital D, and capital D is d by ddx, derivative with respect to x. Okay, in terms of d I have written, then auxiliary equation d square plus 5d plus 6 equal to 0. Then using Calci, or you can find out the roots very easily, but manually also, d equal to minus 2 and minus 3. Okay, d equal to minus 2 and minus 3. Now, complementary factor, roots are real and different, c1 e to the power minus 2x plus c2 e to the power minus 3. This is the complementary factor. Okay, the first part of the solution that we found, complementary factor. Now, the particular integral I am going to find, but what I told you, when we have sin ax function explicitly, cos ax function, or x to the power n function, is algebraic function, where n is an integer, remember. In that case, use short method. Okay, now particular integral I am going to find. Particular integral is 1 by, shift this d operator on the right hand side. This I am operating on e to the power 3x. Okay, so how to do it? 1 by d square plus 5d plus 6, we have to operate on it. So when you, how to operate operator? When you operate operator on e to the power ax, so replace d by a, replace d by 3 directly. If you replace d by 3, so you should not get 0 there. That is the condition. What I am going to do? I am replacing d by 3. So if you get 0, then we have to follow this further procedure. This is 9, this is 15. Now 15 plus 9 is 24, plus 6 is 30, is 1 by 30 e to the power 3x. This particular integral. And solution now, y equal to cf, complementary factor plus particular integral. That's all. Is in this way we have solved this problem. Okay. Now second problem, solve the differential equation. The first one and second one just intentionally I am keeping this differential equation we are going to solve. Y is equal to e to the power 3x. Okay, e to the power minus 3x. Here it was 3x, left hand side is same, right hand side is same. Yes, why did I keep left hand side same? Because of complementary factor, left hand side same, therefore complementary factor is same for first one and second one. Now it remains to find particular integral, because complementary factor in previous sum we have already found. Particular integral is 1 by d square plus 5d plus 6. This operator I have to operate on e to the power minus 3x. Is it? Now what to do? Replace d by minus 3. If you replace d by minus 3, what will happen? If you replace d by minus 3, what will happen? Just you check it. Okay, you can do it separately also. Yes, this is plus 9 minus 15 plus 6 means this is going to become 0 now. And this is not allowed. This is not allowed. Because when you replace d by a, the denominator should not be 0. If denominator becomes 0, then stop for the procedure. Now, what I am going to do, if denominator is going to become 0 for d equal to a, d equal to minus 3 in this case, write down x outside of the operator and take derivative of denominator with respect to d separately. Derivative of d square is 2d, derivative of d is here 5, 5 is multiplicative constant, derivative of 6 is 0 because it is a free constant. Now x again same thing, operate this operator on e to the power minus 3x, put d equal to a again. If you put d equal to a is minus 3. So would you get 0 here? Would you get 0? See, minus 6 plus 5 is minus 1. We are getting non-zero number here. The operator is being operated. Operator is being operated. Okay. Now, minus x e to the power minus 3x is the particular integral. The solution is what? Solution of the differential equation. Y is complementary factor plus particular integral. Complementary factor is same as that of the previous one. Okay, because left hand side of these two are same. So in order to explain this case, this I have taken. Okay, we discuss this sum. Now we operated operator on e to the power ax. Now what I am going to do very quickly solve the differential equation d minus 2 power 3 of y is equal to e to the power 2x. Okay, this problem we are going to solve. Auxiliary equation, it is a coefficient of y is d minus 2 whole cube equal to 0. It is very clear that 3 values of d you will be getting, but d minus 2 whole cube, due to that 2, 2, 2 means 3 values are there, and which are real and equal. These values are real and equal. If 3 values are real and equal, then complementary factor, how do you write? Complementary factor for 3 real and equal values, c1 plus c2x plus c3x square. The position of c1, c2, c3 you can interchange e to the power 2x. Okay, this is the complementary factor, and the sufficient practice we have done on complementary factor. I have written it very quickly. Now, particular integral. Particular integral, operate this operator on this 1 by d minus 2 cube e to the power 2x. Okay. Now, if you put d equal to 2, if you put d equal to a, d equal to 2, the 2 minus 2 will be 0. I am getting 0 in the denominator. So what to write? Write down x outside of the operator and take derivative of denominator separately. Derivative of d minus 2 whole cube is 3d minus 2 square. E to the power 2x is inside of the operator. Now, again, operate this operator on e to the power 2x, means we have to put d equal to 2. If you put d equal to 2, again 0 I am getting. So what I am going to do? Again write x outside of the operator. Here 3 is multiplicative constant in the denominator, you can write outside multiplicative constant. I have written x outside the operator and take derivative of d minus 2 whole square, which is 2d minus 2. operate operator again. X into x is x square because it is outside of the operator. If anything is outside of the operator, no need to worry about that particular term. 3 into 2 is 6, I am writing. 1 by d minus 2 is remaining, e to the power 2x. Again operate operator. How to do it? Put d equal to a. If you put d equal to a, again you are getting 0. 2 minus 2 is 0. So what to do? Write down x outside of the operator, and derivative of d minus 2 is 1. Derivative of d with respect to d is 1, and derivative of minus 2 is 0. Means 1 is remaining. In this way we have removed d, and once you remove d, x square into x is x cube by 6 e to the power 2x. Once you remove d from the denominator, or it may occur in the numerator also, in some cases, then we have solved our problem. Now, solution of the differential equation is y equal to CF, complementary factor, this we found, plus particular integral. Okay. Now, we operated operator on e to the power 2x, e to the power 3x, e to the power minus 3x, in general e to the power ax. Here what we have done, here particularly, we have replaced d by a. We have replaced d by a, provided denominator is not 0. If denominator is 0, then write down x outside of the operator and take derivative of denominator only with respect to d, and follow the same procedure again. Okay. Now in the next sum, we'll deal with the sine and cos function. See, d2y by dx square plus 4y is equal to sine 6x. Is it? Its number may get changed. Instead of 4 and 6, you may be given any number. Okay. Now, complementary factor, this I am writing in terms of d, capital D, right? Then auxiliary equation is d square plus 4 equal to 0. Then d square equal to 4 means d equal to plus minus 2i. This is of the type alpha plus minus I beta. Is it? I am writing in the standard form 0 plus minus 2i, alpha plus minus I beta. The complementary factor by formula e raised to power 0x c1 cos 2x plus c2 sin 2x. Okay, when roots are imaginary and different of the type alpha plus minus I beta, how do you write complementary factor? E raised to power alpha x in bracket c1 cos beta x plus c2 sin beta x. Here in this case alpha is 0 and beta is 2. Okay, and e power 0 is 1. No need to write in the next step. No need to write. Is it? This is complementary factor. Okay, very quickly we found. Now particular integral. Now we have sine function, sine ax function. On the right hand side, operating on sine of 6x. Okay. So what did I tell you? When we operator on sine or cos function, particularly sine ax or cos ax function, in that case, replace d square by minus times a square. A is 6 here. Okay, 6 square is what? Minus 36. 6 square is 36 with minus sign. But replace d square by minus of 6 square. Replace d square by minus 36. But if you replace d square, then you should not get 0 in the denominator. Okay, let us see what happens. Now, minus 36 plus 4 is minus 32. We don't get 0 here on replacing d square by minus a. The operator is operated. This is the particular integral. The solution is what? Y equal to CF plus PI. This is the solution. This is PI and this is CF. Okay. Now, very quickly solve the differential equation d square plus 4 y is equal to sin ax or cos x. There is the same procedure to operate operator on sin ax or cos x. Okay. Here in this sum, in this problem and this one, left hand side is same, therefore complementary factor is same. Okay, complementary factor is what? C1 cos 2x plus C2 sin 2x. Complementary factor. Okay, that we have written here. This is the complementary factor for this because left hand side of these two are same. Now particular integral. Particular integral, we are going to solve this. Particular integral is 1 by d square plus 4 cos 2x. Okay, the same procedure is there to operate operator on sin 2x and sin ax and cos ax. A may be any number. Now, replace d square by minus 2 square. What we are going to do? Replace d square by minus a square, minus 2 square means minus of 4. But if you replace d square by minus 2 square means minus of 4, the minus 4 plus 4 will be 0. Means after replacing d square by minus of 4, you are getting 0 in the denominator. That is not allowed. So what to write in that case? Write down x outside of the operator and simultaneously take derivative of denominator separately. Derivative of d square is 2d and derivative of 4 is 0. Cos 2x. Okay. Now particular integral x by 2 is multiplicative constant, you can take outside of the operator or any term. So as I told you, d is derivative with respect to x, 1 by d, simply 1 by d is integration with respect to x. Okay, this dx I have written because we are integrating with respect to x. 1 by d is integration, x by 2, integration of cos is what? Sin 2x by 2. Integration of cos 2x is what? Sin 2x by 2. In this way, x 2 multiplied by 2 is 4 and sin 2x. In this way, we found particular integral and solution is what? Y equal to CF plus PI. Put CF, this CF and this PI. That is the solution to this differential equation.